3, problem 20. Two loudspeakers in a 20-degree room emit 686 Hz sound waves along the x-axis. If the speakers are in phase, what is the smallest distance between the speakers for which the interference of the sound waves is perfectly destructive? So, first off, it says they're in phase. So we know that the phase change is going to be 0 rad. So then the given, we know that frequency is 686 Hertz and the speed of sound is 343 meters per second. We also know that it is destructive interference. So we're going to be using this formula for phase change. And we can ultimately use this as well. And then for M is going to be a positive number, but we're going to use M equals 0 because it says the smallest distance up here. Smallest distance. So we're going to use M equals 0. So we know these two formulas from previous knowledge and from class and rearrangement of these formulas, and we're going to use them in reference to that. So we have so remember we're using these formulas and we're plugging in for what we have and using this formula, and then we're going to change this to distance because it's the change in x and the speakers are going along the x-axis. So then we're going to cancel out this with this since they're on opposite ends of the equal sign, and we're going to get and then we're going to rearrange so that D comes on the other side. So we're going to get D equals 2, and then this is going to equal 1/2 because we're going to pull this 2 out over here of V over F, which is going to equal 343 meters per second over 686 Hertz times 1/2, and then we're going to get D equals 25 centimeters. And that's the answer. So for number B, or letter B, it's asking if the speakers are out of phase, what is the smallest distance between the speakers for the interference of sound waves to be max constructive? So for out of phase, we know that this value is going to be pi rad this time, and we're using constructive interference. So we're going to use this formula. And then again, we're going to use M equals 0 because it's asking for the smallest distance. And we're going to so we plugged in pi for this because we already concluded that we were going to use pi since it's out of phase. So now what we want to do is we're going to change this to distance because it's a change in x, and then we're going to pull this and push it out so that we can cancel out the pi's. So it's going to look something like this. And then we're going to cancel out these pi's. So now it's technically like a -1. And then we're just going to rearrange and pull the D out because that's what we're looking for. And then we get that. And then from rearrangement, we know that it's... And then we're just going to plug in those numbers that we already know. And then D is going to equal 25 or -25.